accelerated by that amount of potential difference, they enter a magnetic field, and then they travel in a circle. Find the radius of the circle. This is hard. No light, huh? Let's have a look. So, a quick picture, okay?
Where do you see the word circle? Oh, okay.
The voltage here to here, what is it? 3.5 kilovolts. So this causes the electron, which is at rest, to accelerate. And then here it's traveling at some speed v. Okay? But then it enters a magnetic field. Now, using the left hand, okay, which way is the current in my picture? To the left, because it's an electron. And which way is the magnetic field? Into the screen. Actually, I'll make that a little bit clearer. The magnetic field is like this. Into the page. So it causes this to travel in a circular path like this. And the question is, what's the radius? It doesn't actually matter. It'll travel in a circle. Whether it's up or down, it doesn't matter. So, right, you know that F equals mv, well, it equals ma, which equals mv squared over r, because it's traveling in a circle. But you also know, while it's in a magnetic field, the force that is making it travel into a circle is the force that we studied, QVB. That's the force experienced by a charge at velocity v in a magnetic field of flux density b. So here I can cancel that with that, and I can get this formula for the radius. It's equal to the mass of the electron by the velocity of the electron over the charge of the electron by the magnetic flux density.
Teacher,
what?
you just told me that it is the voltage.
No, I didn't. I said velocity.
Oh, okay, sorry.
Yeah, continuing. Now, the problem here is we don't actually know the V. However, yeah, we know that the kinetic energy here is equal to the potential energy here, which means Q voltage V equals a half m velocity squared.
You just say Q voltage V just now again.
No. Q voltage V equals, yeah, for this one, for this new formula. That's for force, this is for energy.
Okay.
So Q voltage V equals a half m velocity V squared. So therefore, 2QV over m square root.
What is V?
Which V?
You say Q voltage V, but you didn't write.
Q voltage V. So this is equal to m square root 2Q voltage V over mass of electron all over QV. Now look, do we know the mass of an electron? Yes. Do we know the charge of an electron? Yes. Do we know the voltage of the field?
Yes.
Yes. And mass of electron, and charge of electron, and flux density. So, by putting all of this into the formula, we can get the or. Is it though?
Yeah. Do we have the formula in the formula?
You do. There is a formula for the radius in the formula.
Is that a guide that, how to use it, when you say it?
Look, if they make it any easier, okay, there'll be no value in doing the exam because they'll just give everyone an A.
Okay.
This formula for the radius is actually in the formula book. Although they obviously simplify it down, you probably cancel the M's and the Q's in some way. You can simplify this to MV over QB.
What is the
No square root?
0.798.
Okay.
Oh, but V velocity, so you still have to go to the trouble. Yeah, okay, so you're not actually gaining much. Yeah. What answer did you get here, Monica, for the radius? 0.798 meters.
Wait, I mean,
We have to wait to let the slow children catch up.
what is the
Patience.
shall we do it as done? Like a, no, I mean like a, you know, like a try for.
You mean, will we do an exam?
Yeah.
Yeah. If you want.
798.
Yeah.
I guess 761. 7.61 times 10 to the negative 16. Why?
10 to the negative 16?
Yeah. Wait, I mean electron, right?
Yeah.
And then square root 2 times constant 23, right?
Yeah.
Times 3.5 kilo,
Yeah.
right?
Yeah.
Divide by constant 23.
Yeah. Oh. Okay, whatever. 798. Right.
Oh, yeah, so teacher, are we doing like an...
If you want.
Yes, because I need motivation to study.
What grade do you need in physics?
I don't know. I mean, A plus, AA.
I think doing all of these questions will secure it. I mean, Monica, you've done a few of these. You're probably noticing that, yeah, there's kind of a repetition to them. You probably noticed it's very unusual after doing it for a while to actually come across a question that looks kind of surprisingly different, you know. Like the transformer question, it's so similar each time. In fact, this one here, Lee, I've seen this one. The calculate the radius of the circle for this one here several times. It's a fairly standard one. Yeah, it's difficult the first time you see it, but not the 5th time you see it. Okay, we can close this.